Factoring based on conjugates. Yesterday's homework had some problems in it, right? And they were two binomials you were multiplying together. Anybody remember that? Like in the back of homework? Say, I don't know, like x plus 5 times x minus 5. You remember when you distributed through twice and combined like terms, what happened? When you combine like terms, the two of the terms just canceled each other out, right? And you were basically left with a pretty simple little pattern you could follow, couldn't you? Right? Well, let's look and see if we can officially establish this pattern here, right? Oh, x plus 5 times x minus 5 is what I just said. So 1a here. Let's distribute through here. Whoops. So this will equal, distribute through the x, and then distribute the 5, and what do we get? Minus 5x, yep. Plus 5x. You see those are going to go away, right? And then minus 25. 5 times 5. What's another way to say 5 times 5? 5 squared, right? Okay? So this actually, because they cancel out, you have x squared minus 25. 5 squared, right? Okay? Let's try the next one. I want you guys to distribute that on your own and tell me what you get. You're done. Go ahead. Did you get x squared minus 4? That's minus there. What?
It's right there.
Minus. So you got x squared minus 2 squared, didn't you? Okay. Let's try the next one. Why don't you all just tell me what you get when you distribute all together, like in the chorus there. 16x squared minus 4x plus 4x minus 1, or 1 squared, right? What is 1 squared? It's just 1, right? So this still fits a little pattern, doesn't it? So in other words, it's 4x squared minus 1 squared, isn't it? Okay. Let's look at D. Slightly different. There's no numbers in here, right? But it should work the same, shouldn't it? So let's, tell me what to get, what we get when we distribute the x. X squared. Let's call it xy. How about we call that plus xy? So they look the same. Right? What is it? Minus y squared. Which the result will be what? Okay. So maybe we're seeing a pattern here, right? So let's try this next one by skipping that middle step there. What do you think it'll be?
Squared minus 3.
Squared minus what now? How about 9? Right? 3 squared. And then in F, let's skip the middle step. What would we get? 25x squared minus 4y squared. Okay? So everybody's seeing a pattern here, right? Okay. So what we have here is it's subtracting, right? And we call that a difference, don't we? When we subtract, it's a difference of 2 what? Squares. Right? Isn't a square the result of squaring something? So what you could call this a difference of 2 squares. And by the way, these are also called conjugates. When you have like a plus b times a minus b, they're called conjugates of each other. Yeah? So that's a new word, right? Okay. And so here's the pattern. This is a pretty handy thing in math. Whenever I have conjugate pairs, as they call them, a plus b times a minus b, the result is always going to be just a squared minus b squared, whatever the numbers or variables are in there. Okay? So let's try these out here. What would this be? Because is it in this form? Equals
Minus 36.
x squared minus 36. Getting the idea? So you guys take a minute and just do the rest of these on your own. Let's see how we do. Okay? Simple one step for each one of them. Get 25x squared minus 4 for B.
Yeah.
How about for C? What is it?
4x squared minus 420 squared.
There we go. You guys are all over this. How about for D?
16 minus x squared.
Mm-hmm. E?
36 minus 25y squared.
Wow.
And then 100x squared
Whoa.
minus 16y squared.
X squared minus 16y squared. So every time we do that, we end up with a difference of what are called perfect squares. You heard the term perfect squares before? Okay. Well, anyway, because there's an equal sign connecting these, you would all agree, I'm sure, that if you saw x squared minus 36, you could then rewrite it and factor it out to this thing up here, x plus 6 times x minus 6, because equal signs work both ways, right? Well, get that? So if you saw this and someone asked you to factor it, what would you write?
I don't know.
Good gravy. I just got done saying it.
X plus 6.
X plus 6 times x minus 6, if you were asked to factor that, right? And this one here, if someone asked you to factor this difference of two squares, what would you write?
5x plus 2 squared.
Yeah, you just have to know that that's a perfect square minus another perfect square, which I think we probably should talk about if you haven't heard that term. You do know what a square is, right? Okay. Let's do this. Before we start actually going the other way, so give you some notes here. All right. Perfect squares. And it'll be helpful to know any of these, right? So perfect square is just a result you get from squaring, a whole number or an integer, okay? And so then when you turn around and get the square root of that perfect square, you get a nice whole number, wouldn't you? So let's list off some examples then, real quick. What is 1 squared equal to, everybody? 1. That means then that the square root of 1 equals what? Huh? 1. Okay?
2 squared.
What is 2 squared? 4. Which means that if I go the other way, the square root of 4 would have to equal what? 2, right? The thing it took to square it, right? What's 3 squared?
6 or
9, which means the square root of 9 equals what? 3, right? You getting the idea when I do the square root? So let's list off some more perfect squares. What is 4 squared? 16. So 16 is a perfect square, right? Because I take the square root of it, I get 4, right? A nice whole number. 5 squared. Let's keep going here. 6 squared. 7 squared. 8 squared. All right, 9 squared. 10 squared. How about 11 squared? 121?
Yeah.
What's 12 squared? 144?
Yeah.
Yeah? And you could go on forever, obviously, right? Okay? So look, these numbers here, I'm going to try and box them in here. Let's see. Yeah. So all of these, I should have been a little more organized with that. All of these numbers that you get when you square a whole number, these are all perfect squares, okay? So if you saw these numbers in a difference of two things, right? These are perfect squares. Because what happens when you take the square root of a perfect square? What do you get? A decimal or something? No.
No, a whole number.
A whole number, right? That was all pointed, right? Okay? Look, see, I'm taking the square root of some of these perfect squares. The result's always a whole number, right? The thing you squared to get it, yeah? Okay. So it's a good idea to get these perfect squares in your head. So you spot them and you see the number 64. Oh, that's a perfect square. I mean, know that, right? You think that would be helpful if we're going to try and go the other way with these things now? Yeah. So let's try and do that then. Okay, so difference of perfect squares. So now they want us to factor these, basically, right? Go the other way. But let's first write it like explicitly as a difference of two squares. So this would actually be x squared minus what squared? That's 9 squared, right? Okay? Now, eventually, you won't have to write this out, you know, as you get better at this, but I want to show you, right? So, knowing that we can also go backwards from the way we did it on the page before, how would this factor out? No, no. Oh, yeah, sorry. I always like to do the plus one for x plus 9, and one has to be minus. X minus 9. Factor. Right? Okay. Is 9x squared a perfect square?
Yes.
Because obviously x squared is, right?
It'd be 3x.
And 9 is a perfect square. So let's rewrite this as,
3x minus 2.
well, hold it, right, 3x squared. Notice how I have to use parentheses there, right? To indicate I'm squaring both of them. Okay. Minus what squared? 2 squared, right? Now it looks like a squared minus b squared, right? So it should just be a plus b times a minus b. So what are the factors then? Plus 2 times 3x minus 2. There you go. You just factored the difference of two squares. What about in C? We know y squared is a perfect square. Is 25 a perfect square?
Yes, 5 squared minus y.
Minus y squared, right? So that would be what? Not and then times, right? 5 minus y, right? A plus b times a minus b. Maybe we can try it now without writing it out like this with the first step, you think?
Sure.
If you need to, you know, when you do it, that's fine. So let's try D. Is 4x squared a perfect square? Is 81y squared a perfect square? Okay.
So it's minus and then plus.
It'd be what?
It'd be like first.
2x plus 9y times 2x minus 9y. I always like to put the plus one first. It doesn't, I guess it doesn't matter, right? It's commutative property multiplication, right? Okay, why don't you guys try these last two on your own, right? I should have put that one down here. mess with this, you guys. Do your thing. I'm trying to move it. There it goes. Yeah. Put it down there. Huh?
You're still recording.
Am I? Oh. What do we got for T there?
11x minus 1. 11x plus 1 times 11x minus 1. Yeah, same thing.
Well, you didn't even say the other one.
Well,
It doesn't matter if you do the plus or minus, but I just
and
was
then
plus.
1 plus 2x minus 2x.
Yeah. 1 plus 2x times 1 minus 2x. Because 1 is the square root of 1, right? Okay. Can I get the idea there? All right. Last one here. I don't want to do this whole thing. They like to do this thing where they're going to have us factor it, right, and then plug in some value of x to see if they're equivalent or not. I don't want to do that. So, looking at x squared minus 9. Are both of those perfect squares?
Yes.
With subtraction in the middle. This will not work with like x squared plus 9. You guys got that, right? You understand that?
Yeah.
Okay? Only with difference of two squares. So this Amelia thinks that it's factored as x plus 1 times x minus 9. Which kind of makes sense, right? Because x times x is x squared, negative 9. I mean, she can't be right, can she? Huh?
No, because it's squared.
Yeah, sort of. Let's just go down here then. I'm going to skip, I don't want to do this table. We're going to plug in some values for x and find that they're not equivalent, right? But let's just do it this way. Let's go the other way with Amelia. So if Amelia says that this factors out to the x plus 1 and x minus 9, then if we were to multiply this, what she thinks it is, we should get x squared minus 9 as a result, right? So let's just check it that way. So let's distribute twice here. What do we get? X squared hello? Minus what? 9x, yep. Plus what? 1x, just x. Minus 9. Now combine these like terms. X squared minus 8x minus 9. Well, that is not x squared minus 9, right? So really, it should be what if we distribute this?
X squared minus 9.
But x squared minus 9, right?
That's what I said.
Okay, yeah, sorry. My brain skipped a beat there. Okay? And it has to be two perfect squares with a subtraction sign in the middle. Difference of two squares. It does not work with a sum of two squares. You understand that? Really quick. Before we get to the Regis questions, there is a thing I need to show you. We'll call this number 2. It's real quick. We know that x squared is a perfect square, right? Okay. What about x to the 4th power? Thinking about your properties of exponents. Should we consider that a perfect square? What?
Yes, because it's x squared.
Aha, right? X to the 4th, properties of exponents is actually x squared, isn't it? And so it's a perfect square, okay? What is the square root then of x to the fourth? Yeah, it's actually, so you're basically taking the square root of x squared squared, right? And square root undoes what? Squaring. Only one of them though,
There's
right?
so much square going on. Square.
That's fine, yeah. But it only undoes one of them, right? So you get x squared. Okay? What about the x to the sixth power? Could that be a perfect square?
X, x cubed squared.
Yeah. 3 times 2, right? So the square root of x to the sixth would be x, right? But anyway, just keep that in mind. So let's go to the Regents' questions then. Okay? By the way, the very first thing you always look for when you go to factor, always, make a note here, is a GCF. Always. Sometimes there's not one. Always look for a GCF first. Okay? Because there might be other factor you can just add to that. Okay? So let's take a look at this number 1 here. 18x squared minus 50. And it looks like they want us to factor it. And so what should we look for first? GCF. So 18x squared minus 50. What would be the greatest common factor between those two terms? Well, 3 won't go into 50. Like yesterday, GCF. Just 2, isn't it? 2 is the only thing, right?
Yeah. No.
10 won't go into 18, right? It's got to go in evenly, right? Yeah, sometimes, right? So so 2 is just the GCF, right? So if I factor out a 2, then what's left?
X.
What?
9.
9x squared minus 25. Okay? Now, you see the thing in parentheses? What is that? Is that a difference of 2? Is 9x squared a perfect square?
Plus 5.
Is this a perfect square? Is that a perfect square? All right, make sure you identify it's a perfect square first, right? Because sometimes if they're not perfect squares, then you can't do that thing to it. Huh?
Number 3.
Right? So, this would actually be 2 times what? 3x plus 5 times x minus 5. A plus b times a minus b. So which choice?
3.
Yep. Choice 3. But like, see what they do to you sometimes there? Some of you kids will forget to take the square root of 25 or something like that. Okay? All right. All right, you guys try number 2. And always look for a what first? Yeah. If there isn't a common factor, then don't worry. Then move on to, the next technique. Are both of those perfect squares, guys? Yeah. Is it a difference of 2 perfect squares? Hmm? Is it a difference? Yeah, so minus means difference, right? So what's the answer to this, number 2? Gonna be choice 3, isn't it? What's the square root of 16?
Oh, 4.
What?
I thought you said that, like, it's both the same numbers as one both of them, right? Like,
Oh, no, there is no GCF. We always look for one, but there isn't. Like up here,
So it's just 1.
up here there was a GCF. And then we got a difference of 2 squares. But down here, there is no common factor.
That's what I've been.
So we do that. So now we know that that's a perfect square and that's a perfect square. So it just becomes what, guys? 4x plus 9
4x
minus 9. Choice 3, right? But see, for all you guys that think taking the square root means dividing by 2, they put the 8x in there. Okay?
I was trying to find the GCF.
Yeah,
But there
which you should always do first, right? But there just isn't one in this case.
Yeah.
But always look first.
I kept dividing 81 by whole to numbers that went into 16 and 1.
Yep, that's valid. Like the more you do that, the more you'll be able to spot. Say, all right, I know there's no common factor, right? Because you'll remember a time when you tried that, right? Okay. Now, number 3, there's a typo. Okay.
I was so confused.
There is a typo in number 3. You see where it says w squared here? That should be w to the 4th. Hence the reason I gave you that note. All right? Well, hold tight then. So this w to the 4th minus 36 will equal something. What's your answer, Serenity?
Number 3.
Serenity says,
4.
so, oh, now you say 4?
Yeah.
You guys agree with her?
Yeah.
You sure? I wonder. Are you sure it's 4?
Yeah.
Let's find out. I'm going to just spell this one out explicitly, see if we can write it like a squared minus b squared, because it's a little different than the other ones, right? W to the 4th is actually what? W squared, right?
Yeah.
Minus 6 squared. So that's a squared minus b squared. So it's what? W squared plus 6 times w squared minus 6. And Serenity was correct. I was just toying with you a little bit there, see? Because when you start being correct, then you have to start feeling confident in withstanding a challenge to it, see? So that's the next step. You did it. Yes, ma'am. Okay, well, slow down, hang on. Let's everyone else take a look at the next one. First thing you should look for always is a what? Always do that first. A lot of times there's not one, but always look first, okay? Because you saw that first problem. It made a world of difference when you pulled that out. Well, what is the answer? Sam, what'd you get? What'd you get? Or is that a difference of 2 perfect squares? Okay. So how's it affect? It's a squared minus b squared, isn't it? So a plus b times a minus b. What's a? If a squared is 4x squared, 2x, and what's b? Yeah. So what is it? Plus, yeah, well, either one. Oh, no, I was like the plus first, but it doesn't matter. Times minus 5, yeah.
3
Is
and
that-
4 are the same. What's the difference between 3 and 4? Yeah, but
It does-
it doesn't matter.
2x plus, that might be a typo. Huh. Yeah, I think this is a typo. Yeah. Anyway. Yeah? Gonna get the hang of it now? So you know how to factor difference of 2 squared, but always you should look for a what? GCF first. I don't know that there'll be any in this homework, right, but the next section, right, I think there'll be some more of those when we pull out a GCF. First, guys, I'm gonna have you skip number 4 and 5 in the homework, okay? So skip numbers 4 and 5 in homework. Okay? There we have it.